These are the notes for the second half of section 9.2. You were given some time at the beginning of class today to try these 3 review questions from yesterday's material. So now we're just going to check through them. On our first one, we need to set up an augmented matrix, and that's listed here. You want to make sure on the test to show me your initial matrix that you're putting into your calculator, as well as the solution matrix listed here, so that if you get something wrong, I can try to track down where your mistake was. So for our first one, we are putting all of our x coordinates, or our x coefficients, in our first column. Our second column would have all the y's, our third column has all the z's, and our fourth column has all the w's. And that's based on the order that you see your variables right here. Typically, when we write our final answer, we put them in alphabetical order. So the correct answer, looking over here, is to say that w is 4, x is 0, y is 1, and z is -3. All right, so when someone looks at an ordered quadruple here, we're assuming it's alphabetical. All right, looking at question 2, we've set up an augmented matrix in our calculator. I've listed your solution matrix here. And I want you to focus on the last row, the one I circled in green. Notice that we have no variables here, and it's supposed to equal 1. And that can't be true. 0 cannot equal 1. So this is one where we would say there's no solution. And then the third review question, again, we're setting up an augmented matrix, okay, which I have here. Then we use the calculator to do our REF, and we get our solution matrix. Now notice here we had 3 variables but only 2 equations. So in that situation, there's no way to get a single answer like we got in our first example. We would have to get the infinitely many or no solution option. So for this case, we have infinitely many solutions. When we look at our first equation here, we are told that x equals 2. All right, so we automatically know that x is 2. Then we look at our second equation. This would be our y. So we have the equation y minus 1/2 z equals -1/2. And then if we bring this -1/2 z to the other side, we get our expression for y. So that's where this solution came from. X is 2, y is the 1/2 z minus 1/2, and z can be anything. All right, so now we're going to shift to looking at how do we apply these to some real-world situations. Our first example says the figure shows the intersections of 4 one-way streets. They're asking us to set up a system of equations that keeps traffic moving. Basically, each intersection is going to create an equation. We want the number of cars entering to equal the number of cars leaving the intersection. So the one thing I want you to do is when you're looking at this map, first of all, notice the arrows. So it's giving us an indication of which way the traffic is moving. Then the other thing to do is to focus on one intersection at a time. So for the first equation, I'm just going to focus on this first intersection, looking at what's going in and what's going out. So based on my map, I have 170 cars going in. There's an arrow pointing to the right. Coming out is this W here. Okay? So going in is 170, coming out is W. The other direction, we have 190 going in, and we have Z cars coming out. Now, that doesn't mean that Z is equal to 190, because those 190 cars that are entering could continue straight down and be counted in Z, or they could make a turn and be counted as W. But basically, we want to have the number entering and the number leaving to balance. So for my first intersection, I would say going in, I have 170 plus 190. Coming out, I have a W and a Z. Okay, so we're just going to start out writing those equations, and then we'll convert them into a matrix format. All right, intersection 2. Again, focusing on the arrows. We have W going in and 190 coming out on that street. Our vertical one, we have X going in and 380 coming out. So now we have a W and an X going in, and coming out we have 190 plus 380. All right, intersection 3. My arrow is pointing this direction and this direction. So going in, I have 190 and I have Y. Those are the pieces going into intersection 3. Coming out, we have 30 cars and we have X cars. All right, and then our final intersection, going in, we have 125 and Z. Coming out, we have Y and 75. Okay, so we have an equation for each intersection. Now we need to rewrite them so that we can put them in a matrix format. The first thing to do is to get all of your variables on one side. That might mean we need to do some maneuvering here with our equations. So for our green one, the top one, we have constants on the left side, we have our variables on the right. Typically we have those reversed when we write it as a matrix. So I'm just going to flip-flop the two sides. So I have W, I have no X's, no Y's, and I have a Z equaling, if I add 170 and 190, I get 360. Okay, my second equation, the red one, is already okay. I have the W and the X on this side, and it equals 190 plus 380, which would be 570. My third equation, this one has a Y on one side and an X on the other. I need to put those both on the left side. So I'm going to subtract an X, and I'm going to still have the Y that was already there. On the other side, I'm going to subtract the 190 over, which is going to put me at negative 160. And for my fourth equation, same thing, I'm going to have to bring the Y to the left side, so it's going to be a negative Y. I already have a Z over there, and that would equal, if I bring the 125 to the right side by subtracting, I'm at negative 50. Okay, so I want to create a matrix out of this. So looking at my top row, we're going to have W's, X's, Y's, Z's, and then our constant. My top one, I have one W and I have one Z. I have no X's and no Y's. My constant is 360. For my second equation, I have one W and one X, but no Y's and no Z's, and I get 570. My third equation, I have no W's, negative 1X, positive 1Y, no Z's, and a negative 160. And my last equation, no W's, no X's, negative 1Y, positive 1Z, and negative 50. All right, so that's the augmented matrix that I'm going to type in my calculator. I'm going to let it do the RREF, getting it into reduced row echelon form for me. All right, and go ahead and pause the video here. Go ahead and enter that in your calculator, and then turn the video back on. All right, checking our answer matrix. We should have 1, 0, 0, 1, 360. Our second row, 0, 1, 0, negative 1, and 210. Our third row, 0, 0, 1, negative 1, 50. And our final row, all zeros. And again, what that tells me is that my Z variable can be anything. All right, now let's figure out our other variables. My second row, I have 1Y minus a Z equaling 50, which means if I add the Z over, Y is going to be Z plus 50. My second row, that one says an X minus a Z equals 210. So X would be positive Z plus 210. And my top row is telling me that a W plus a Z is equal to 360. So W would be negative Z plus 360. All right. So my solution we said W is negative Z plus 360. Sorry, I'm noticing a mistake here. All right, and then my X was Z plus 210. My Y was Z plus 50, and Z could be anything. All right, so there's my solution. It's an infinite number of possibilities. So now part C says, if construction limits Z to being 45, how many cars per hour must pass between the other intersections to keep traffic moving? So we're just going to plug a 45 in. So 45 plus 50 would be 95. 45 plus 210 would be 255. And negative 45 plus 360 would be 315. So going back to our map, if we have W being 315, W is right here. That means there's 315 cars moving between intersections 1 and 2. We said X was 255, so this value would be 255. Y was 95, so we have 95 cars moving between intersections 3 and 4, and Z was 45. All right, so that's just one possible solution based on Z being 45, but we could alter that if the construction gets cleared up. All right, for our second example, it says 3 foods have the nutritional content per ounce shown in the table below. A diet must consist precisely of 176 units of vitamin A, 144 units of iron, and 272 units of calcium. It says, however, the dietitian runs out of food 1. So that means we are not allowed to use this at all. It says, use a matrix approach to show that under these conditions, the dietary requirements cannot be met. All right, so we're going to create 3 different equations, one for each of our types of nutrients. The vitamin A, again, we're looking at this column, but we can't use food 1. I'm going to call these X, Y, and Z. So based on my vitamin A restriction, or requirement, I get 24 units for every ounce of food Y, and I get 8 units for every ounce of food Z, and I need 176. For my iron requirement, I get 8 for every Y, 8 for every Z, and I need 144. And for the calcium, I get 8 for Y, 24 for Z, and 272 is my requirement. So we're going to create an augmented matrix based on that. So 24, 8, 176, 8, 8, 144, 8, 24, 272. And we're going to let the calculator do our RREF, so go ahead and pause the video and get your solution matrix. All right, you should have 1, 0, 0, and for our next row we should have 0, 1, 0, and our final row 0, 0, 1. And we focus on noticing right here that we have 0 variables and it's supposed to equal a 1, and that can't happen. So we have shown that under these conditions the dietary requirements cannot be met. There's no solution to that. Now the last piece says, what if food 3 is now available? So let's go back and we're going to be able to use food 3. All right. And now we want to look at the requirements just for iron and calcium. It says use matrices to give two possible ways to meet only the iron and calcium requirements. So this time around, we're not even going to bother with vitamin A. We don't care about that. We just want to meet our iron and calcium requirements. So we're going to create a matrix again. Our equations would be 16x plus 8y plus 8z having to be 144. So that's this piece. And then for calcium, now we have 8x plus 8y plus 24z, and we want it to be 272. So we're back to having three variables, but we only have two equations. So we're never going to get a single answer here. We're going to get that infinitely many option. All right, so we're going to put this in our calculator, and we're going to let the calculator get it into reduced row echelon form. So again, pause the video and try that. All right, your solution should look like 1, 0, -2, -16, and 0, 1, 5, 50. So interpreting this, first column was x's, second y's, third z's, or food 1, 2, and 3. So this means that z can be anything since we don't have a third equation. My second equation says y plus 5z equals 50. So if I subtract my z's, I get negative 5z plus 50 for my y piece. And my top row here tells me that an x minus 2z equals negative 16. Or again, solving for x, we'd have 2z minus 16. So our solution, we've got 2z minus 16, negative 5z plus 50, and z can be anything. Now they said give us two solutions, two possible options that would meet those daily dietary requirements. So the first thing to look at is we can't eat negative number of ounces of food. So our solutions here cannot be negative numbers. We could have 0, meaning we don't eat any of a certain food. So what is the smallest value and the largest value of z that would work? Well, if we put a 10 in here, my y value, all right, my y value would be 0. So if I put a 10 in for z, I'm going to get nothing for y. I don't eat any of that second food. And if I put a 10 in here, I end up with 20 minus 16, or 4. So one option is that I can have 4 ounces of food 1, 0 ounces of food 2, and 10 ounces of food 3. Okay? If I look at my x requirement here, if I want this to not be negative, the smallest number I could put in there would be an 8 for z. Okay? So if I put in 8 ounces for z, my x coordinate now is 0. My y coordinate, if I put an 8 in there, gets me 10. So a second option would be none of food 1, 10 ounces of food 2, and 8 ounces of food 3. Now, our z value, the maximum it can be is 10, the minimum it could be is 8. So we have another option. We could put in 9 ounces for z. If I put a 9 in here for y, I get negative 45 plus 50, so I've got a 5. So 5 ounces of that second food. And if I put a 9 in here, I get 18 minus 16, or 2 ounces. So that's a third option that would work. All right, so your assignment, section 9.2, day 2, page 885, questions 25, 27, and 29 to 35. Make sure you show your work.